In this final video of the series, we are going to take a look at the famous, or rather infamous, double-slit experiments. The results of these experiments have plagued scientists for a long time. They lead to conclusions that particles can be waves, and whether they are not depends upon whether someone observes them. Even more weirdly, these experiments suggest that the common sense idea of cause and effect can be broken and time can run backwards. We're going to see in this final video how a quantum process and HOLON view of reality can restore common sense to science. We will summarize what we have found out in this series and compare how a common sense universe made of quantum processes and HOLONs stacks up against a particle and space view. I hope you enjoy the final video in this series, and that you have found the complete set interesting and enlightening. At the end of the video are thanks to some of the people who made these videos possible. So let's have a look at these double-slit experiments. The left-hand side of this diagram shows a photon gun that can shoot photons, particles of light, toward the detector screen. To get there, they have to pass through a small slit in another screen. As one would expect, the photons pass through the single slit and hit the detector screen in line with the slit. So our scientist, the little stick man, concludes that the photons are acting as particles. So now the scientist decides to have a look at what happens when they put two slits close together. They are in fact expecting the two-slit outcome illustrated on the right-hand side of the diagram. That is, they expect some of the particles to go through one slit and some of them through the other. But to their surprise, this is not the case. In the center, the detector screen shows a diffraction pattern that indicates that the light is behaving like a wave. This is very puzzling. How can light be a particle and a wave? Our scientists decide to look at things more closely. Here in the center diagram, our scientist has built a very sensitive and sophisticated photon detector. It is so sensitive that it can tell when one photon goes through a slit without disturbing the photon's path. When he has finished building this sensitive detector, our scientist has a look at the pattern that is building up on the detector screen. The screen is showing a diffraction pattern, showing that the light is behaving like a wave. Our scientist is hoping to find out how it is that this single photon particle can suddenly become a wave and then interfere with itself and then contribute to a diffraction pattern that is building up on the detector screen, one photon at a time. So now our scientist switches on his machine. He is astounded to see that the diffraction pattern disappears, and in its place there appear two pools of light that correspond to particles from the photon gun going through one slit or the other, and then carrying on in a straight line to hit the detector screen. Our scientist switches off his machine and the diffraction pattern returns. By toggling his machine on and off, our scientist can switch between the diffraction pattern and particle pattern at will. They conclude that somehow the act of observing light determines whether that light acts as a particle or a wave. Well, if our scientist was puzzled by why light could behave as a particle and a wave, he is now even more confused, because it seems that merely by looking closely at the light, he can force it to be a particle. This interpretation leads to rather strange conclusions. That, when light is observed in some unknown way, its wave function is collapsed and it becomes a particle. Now these ideas are so outlandish that our scientist thinks up another experiment. This experiment is called the delayed choice experiment. Amazingly, all our scientist has to do to carry out this experiment is move his very sophisticated photon detector behind the detector screen that shows the pattern. This apparently trivial change is very important, because now, when the photon detector is looking at the slit, because the speed of light is constant, it cannot see the photon it is trying to observe before that photon has gone through the slit and hit the screen. Our scientist is expecting that moving the photon detector behind the detector screen will mean that even when the photon detector is switched on, the interference pattern will remain on the screen. And the result of this experiment is that as long as the machine is on, the photon acts like a particle. Toggle the switch on and off, and the scientist toggles on and off the particle pattern or the interference pattern. It is difficult to underestimate what a disaster the outcome of this experiment is for conventional science. It appears that universal rules of cause and effect have been broken. We have the effect of a particle pattern or an interference pattern being determined by an observation that takes place after the event. Short of some bizarre way that during this experiment time could somehow go backwards, there is no rational explanation for this result. So the double slit and the delayed choice experiments throw up challenging questions. How can light be a particle and a wave? How can observing something change its nature? And how come we can do an experiment that seems to breach the rules of cause and effect? Let's have a look and see if the quantum process and HOLON paradigm gives a better explanation for these experimental results. On the upper left-hand side of this diagram is a representation of a photon HOLON. Just as with any other HOLON, it consists of vast numbers of quantum process electrons oscillating between the HOLON boundaries. This structure is effective at solving the particle and wave paradox, because a photon HOLON is a collection of oscillating standing waves. But because they have boundaries, they have what appears to be a particle nature. The boundaries that enclose the oscillations mimic the boundaries of what in the particle and space paradigm would be considered to be a particle boundary. So how do photon HOLONs behave as a particle and a wave in the experiments we have just looked at? Well, the particle-like behavior is the easiest to explain. All of the photon HOLON, together with its integral boundaries, pass through one or other slit, building up a two-spot pattern on the detector screen. The wave-like behavior is observed when the photon HOLON's boundaries are disrupted and some of the photon HOLON's oscillations go through one slit and some of them through the other. On emerging from the slit, the oscillating waves interfere with each other and produce the interference pattern on the screen. Solving the dilemma of how a photon HOLON can behave as a particle and a wave is, however, only an enabling explanation. We still have to determine why photon HOLONs display different behavior in apparently identical experiments. Let's have a look at these experiments again. We need to remind ourselves that earlier in this series we discovered that the quantum process that builds all HOLONs has quantum awareness as one of its interfunctions. And we showed that as HOLONs become more complex, then their awareness becomes more complex. We demonstrated how life and consciousness emerge in ever more complex HOLONs. We are going to look at these experiments from the point of view of HOLON awareness. Let's first have a look at the double slit experiment exhibiting particle behaviour. Highlighted in red is what we can call the experiment HOLON. You can think of it as the room in which the experiment takes place. We'll take it that this experiment HOLON has a certain level of awareness. In particular, with the photon detector switched on, it has a level of awareness that is capable of tracking a photon deterministically from the moment it leaves the photon gun until it arrives at the detector screen. So the experiment HOLON knows which slit every photon HOLON will go through. Just two pools of light appear on the screen as the photon HOLONs apparently behave as particles. So what happens with the delayed choice experiments when the detector is put behind the detector screen? On the right, highlighted in red, is the delayed choice experiment HOLON. And we see immediately that in HOLON terms the two experiment HOLONs are identical. They have the same internal level of awareness. So these experiments give identical results. The experiment HOLON tracks the paths of the photon HOLONs deterministically from when they leave the photon gun until they reach the detector screen, and produce the particle type pattern. So what about the experiment where a diffraction pattern is obtained on the detector screen? Highlighted in green is this experiment HOLON. The essential difference about this experiment is that it is not the same experiment as the previous two. The photon detector, that is a very complex HOLON in its own right, is missing from this experiment. As a result of this experiment HOLON has a much lower level of awareness than the other two experiments. This experiment HOLON is only able to determine the position of the photon HOLONs until they reach the split screen. Once photon HOLONs reach the other side of the slit, the experiment HOLON has no way of being aware of which slit any particular photon went through. The best it can make of the information it has is that half of the HOLON's quantum oscillations go through one slit and half through the other. This means that the two halves interfere with each other, and as the experimental HOLON makes the best of the information that it has, it builds up an interference pattern on the detector screen. It is also worth noting that if we add a switched off photon detector to this experiment, the awareness level of the experiment remains the same. The deterministic particle pattern can only return to the screen when the photon detector is turned on and the awareness level of the experiment HOLON is increased. Unlike the particle and space view of reality, the quantum process and HOLON view of reality enables these experimental results to be explained in a consistent way, without mystery and without the need to have time running backwards. Of course, this explanation sounds as if we are indulging in the personification of these experiments and their components. This is not the case. In the quantum process and HOLON paradigm, quantum awareness is an integral part of the quantum process, every bit as integral as charge and space and boundaries. So, as we saw earlier in the series, awareness builds up in HOLONs. The more complex the HOLON, the more complex the awareness. These experiments support this fundamental idea of interfunctionality and the idea that everything in the universe is to some degree aware. Of course, human HOLONs are extremely complex. We have a particularly complex level of awareness that we call consciousness. So whereabouts does our stickman scientist fit into these experiments? In the left-hand experiments, the scientist is outside of the experiment's holon. They have no access to any information about the experiments. The experiment's holon may be running in automatic, with data being gathered. But the scientist or anyone else outside the experiment's holon cannot find anything about this data. In the central experiment, the scientist has entered the room and become a part of the experiment's holon. They are able to look at the screen and the on and off status of the photon detector. The scientist's holon and the experiment's holon are then both aware of the link between the status of the photon detector and the state of the screen. In the right-hand experiment, the scientist shares the experimental data with other people, making them aware of what happened inside the experiment's holon. The result of this experiment becomes common knowledge, knowledge in the wider world holon. This quantum process and holon explanation of the double-slit experiments gives us a rational explanation of a rather famous thought experiments. In 1935, Erwin Schrödinger, when discussing quantum uncertainty with Albert Einstein, suggested this experiment. He put a cat in a box with a random event generator. This could be, for instance, a radioactive decay counter. A system is set up so that if a decay takes place, the generator releases acid into a bath of cyanide. The hydrogen cyanide released kills the cat. This experiment was devised to facilitate the discussion of superimposed quantum states required by conventional quantum theory. This supposes that while the cat is in a closed box, it is in a state of quantum uncertainty, neither alive nor dead. It is only when the box is opened and the experimenter looks inside that they collapse the wave function. And it is this act of observation that determines whether the cat is alive or dead. This bizarre explanation involving a cat that is at the same time both alive and dead until observed sums up the inability of the particle and space model of the universe to explain reality in a rational way. The quantum process and holon explanation of this experiment is far more straightforward, does not require some weird cat state. The box is an experimental holon, and so it has boundaries. If the random event generator does not produce a decay, the cat remains alive. If the generator produces a decay, the cat is poisoned and is dead. Within the confines of the experimental holon, the cat is alive until maybe a random event makes it dead. The cat is never in any superpositional quantum state. When the experimenter opens the box, the reality of the experiment's outcome, the reality in the box holon, joins with the external reality, and the experimenter and anyone else who wants to know about the death or non-death of the cat can do so. This is another example of universal awareness. So what advantages does the quantum process and holon view of the universe give us, over and above the traditional particle and space view? This series has been about an investigation into how reality and consciousness are inextricably linked. The basic building blocks of the universe are taken to be a quantum process that consists of a pair of oscillating quantum electrons. This process has many interfunctional properties, such as quantum charge, quantum space, and quantum boundaries, that relate to physical reality, and quantum awareness and quantum sentience that relate to consciousness. Treating the universe as an infinite quantum process field allows that the infinite space field, the extent of the universe, as an inextricable, interfunctional, infinite awareness field. The electrical repulsion between the quantum electron pairs of a process accounts for quantum processes expanding and making more room for themselves. A hierarchical holarchy of increasingly complex holons can be built with this expansion as the driving force. Holons can be recognized by their boundaries. Crucially, as they increase in physical complexity, they increase in awareness complexity. This leads to a universe that has various levels of awareness. Inanimate objects have very limited awareness, limited to where they are in relation to everything else. As complexity increases, we recognize more awareness. Viruses have a level of complexity that puts them on the cusp of being alive. Single-celled organisms are more complex and definitely alive. They have a level of sentience that allows them to seek food and grow and reproduce. More complex cellular organisms, such as plants and animals, have increased levels of sentience, and humans have a level of awareness that we call consciousness. The table on the left shows the wide range of phenomena that have been explained by a quantum process and HOLON approach to reality and consciousness covered in this series. It includes explanations for physical realities, the existence of space and time, structure and form, and the material world of solids, liquids, and gases. But it also explains phenomena related to our human condition, throwing light on how we think, what our minds are, how we make up our minds, and where our emotions come from. It explains how we can be of balanced or unbalanced mind, and the dangers of groupthink. It also casts food for thought on the nature of cosmic consciousness, absolute sentient power, spirituality, and religions. It does all these things in a consistent and logical way. This explanation of reality and consciousness could be seen as an unprovable speculation. However, the 4 videos that make up the 12th part of this series show how science and mathematics back up these ideas. We discovered a straightforward view of how atoms, atom holons, are constructed from a single type of electrical charge. A better explanation for some basic electrostatic experiments without anomalies. A minimum size for holons based on the speed of light that is linked to the apparent expansion of the universe. A simple explanation for the Casimir effect. A method for calculating the force of gravity between objects based on electromagnetic principles. Hence, a unification of the 4 forces of nature into the one electromagnetic force. And finally, a consistent interpretation of the double slit and delayed choice experiments. These experiments demonstrate that the universe has awareness as a fundamental property. There is no requirement for photons to mysteriously change from particles to waves at the whim of an observer, and time is not required to run backwards. Schrödinger's cat is alive or can rest in peace without being in some uncanny alive and dead state. So, is reality and consciousness best described by particles in space or by quantum processes and holons? We have 2 competing idea holons. The particle and space idea has a long and distinguished history, but as we have seen, it has its problems. These videos argue that a quantum process and holon paradigm can do a better job of describing reality and our consciousness of that reality. They argue that there is a better way of describing the human condition, a better way of understanding ourselves and how we fit into the universe. Compared to the dead particle and space paradigm, the quantum process and HOLON paradigm describes a universe that is eternal, full of life, hope, and possibilities. These ideas are, of course, embryonic and challenge long-established truths. In order for the process and HOLON paradigm to grow, many people, particularly scientists, need to subscribe to it and improve on it. It seems to me a paradigm worth growing. Whether or not it does really depends upon you. No work of human endeavour comes from nowhere, and this work is no exception. My role has been to weave together the ideas of many extremely talented people in many disciplines into what I hope is a consistent, interesting, and enlightening narrative. Throughout these presentations, I have tried to reference where the ideas have come from, but I would also like to acknowledge them again here, and add acknowledgements to the many other people who have in various ways helped this work come about. The conclusions, and of course the inevitable errors, are all entirely my own. So thanks go to quantum physicists. The idea of quantum entities has a long history with many different interpretations, but perhaps the aspect of quantum theory taken up here is Max Planck's postulate that electromagnetic energy can only be emitted in a quantized form. In other words, it can only be emitted or absorbed in multiples of an elementary unit. In this work, the elementary unit is the quantum process, that is, an electromagnetic oscillation. Thanks also go to the mathematician and philosopher Alfred North Whitehead. Whitehead argued that reality consists of processes rather than material objects, and that processes are best defined by their relations with other processes, thus rejecting the theory that reality is fundamentally constructed by bits of matter that exist independently of one another. This is an idea developed throughout the series. Thanks also to Arthur Koestler. His book, The Ghost in the Machine, published in 1967, introduced me to the concept of holons, which explains so very much when they are constructed from quantum processes. Thanks also to Eugene Halliday. His book, Reflexive Self-Consciousness, in which he sets out the fundamental importance of sentience, interfunction, boundaries, absolute sentient power, and reflexive thinking, were instrumental in providing the language and ideas to put these videos together. And to Michael Faraday for the scientific concept of a field. The route to the unification of reality and consciousness rests on the idea of an interfunctional quantum process field that includes, among others, Faraday's electric charge field. And to Carl Jung, who regarded the psyche as made up of a number of separate but interacting systems, including the ego, conscious mind, and the subconscious mind. These ideas helped enormously in setting out the ideas of how social holons accounts for how we think, where our emotions come from, and their link to mental health. And to Irving Janis for his discovery of the terrifying reality of groupthink. There are, of course, many other people whose works have influenced me and who in one way or another have contributed to these presentations. I could go through my library and internet searches and I wouldn't know where to stop. So to mention just a few people whose works I found inspirational, they include Sir Fred Hoyle with his work promoting a steady-state theory of the universe, Rupert Sheldrake for his work on morphic fields and the habits of nature, and Gottfried Wilhelm Leibniz for his ideas on monads in his book The monadology, a forerunner perhaps of HOLONS, was envisaged over 300 years ago. I am of course also indebted to family, friends and colleagues who have over the years listened to these ideas in the making and not thought me completely insane. So thank you to long-standing friends, including the Borderliners Creative Writing Group, who have kept my imagination working and my writing skills in a reasonable condition over many years. Thank you also to friends made at and through the Chester Lodge of the Theosophical Society. Their speakers were inspirational, as were the informal discussions and meetings. Also to people I met through the scientific and medical network, and thanks to members of the Eugene Halliday Association, particularly the reading group, who helped me appreciate Eugene Halliday's work and ideas. I have unfortunately missed out many people who have contributed to the narrative built up in this series. The narrative has grown organically over decades. I have long since lost the thread of how everything came together. So if you have seen here aspects of your work, and I have not mentioned you by name, I apologize, and I thank you profusely. My biggest thanks go to my family for their love and support, and particularly to Judith, my wife of over 50 years. She has patiently allowed me to spend endless hours over years and years, lost in thought, buried in a computer screen, or under piles of scrap paper. She has looked after my real-world needs while I have been indulging myself in this project. I love her dearly, and I owe her a great deal.